All right. Our question today, we had to use the bird seed graph in the upper right-hand corner to do problem 6 and 7. How many kids, just before we begin, how many kids did problem 7 before you did problem 6? Or use the information from problem 7 to do number 6? Does that, how many kids did problem 6, then jumped to problem 7, figured out problem 7, then went back and said, oh wait, I can use that can you use the information from problem 7?
Yes.
Okay. Today we're going to make a definite connection between using that information and talking about what you watched in your video for 4-4. Okay? So I'm going to start off right now with number 7. And then I'm going to show you how you can use it for number 6. And then I'm going to show you how we can create a table and use a function and inputs and outputs to figure out these different values. Does that make sense to everybody?
Sure.
And then we're going to try and cover as much as this over here as possible. Even though the only things that were required or that you need to know for lesson 4-4 were inputs, outputs, and functions. Okay? We're going to make connections to them all today. And then we're also going to get into this equation right here. And we're also going to talk about unit rates and how they're related to slopes. So we're going to get the whole meal deal today. You ready? Big one to listen to. And if you have to, that's why I'm making a video. It could be a little bit longer, but that's okay. You'll have something you can look at and review back at home. All right. So how do we find the price for each pound of bird? Does anybody know that math nerdy term that we call price for each pound? Price for just 1 pound. It went all the way back to unit 5. I just heard it whispered. Can you just say it louder? Unit rate. Everybody hear that? How much for 1? How much for 1 pound? So how much was it for 1 pound of birdseed? And really all you had to do is go like this. 1 pound of bird feed is exactly $2. Okay? So our answer for number 7 was D, $2. Now, how can we use that to find 6? Well, it says, what would you expect to pay if you needed 3.5 pounds of birdseed? Well, if it's $2 for every pound, couldn't we take 3 1/2 and multiply it by 2? Or 2 times 3 1/2. I wish I would have written it that way. Because I'm going to distribute that 2 to both the 3 and the 1/2 right now. Okay? What is 3 times 2? 3 times 2 is 6. Then we can add that to half of 2. What's half of 2? 1. So it's a grand total of 7. Now, if we actually went to our graph and found out here's about 3 1/2, and if we drove straight up that line, we'd say, boom, it was right there. Did you guys use the graph that way to do it?
Yes.
Okay. Maybe some of you did this right here. So, how many kids did this right here to figure it out? Okay, a few. Now, what I want to do right now is take it beyond where we don't necessarily have to use the graph. We can use pure mathematics to solve. Okay? Does everybody agree that there is an x value on this graph right here? An x value and a y value? Is there? What's the x value called on this graph? Okay, so I'm going to call this pounds. And what's the y value? So I'm just going to put the $sign right here. Okay? And then if you watched your video today, Basically, we created tables that look like this. This should look somewhat familiar to you. Is that correct?
Yep.
Okay. Now, over the next few lessons, they're going to do a couple different things. One, they're either going to give you this part right here, which you guys last year called the rule. Okay? You called this your input, and you called this your output, and you put this value into the rule, and you got out this. Is that correct?
Yep.
Now, we're still going to call this input. We're going to still call this output. This is going to change. Instead of a rule, we're just going to call it a function. Okay? Now, when we go through and do this, we can say 1, 2, and then once we have a rule, we can even figure out how much 10 pounds is, how much 100 pounds is. Or 1,000, you know, maybe you're buying 1,000 pounds. I don't know. Maybe you have some hungry birds. And based on, now that we have this graph, we can figure out the actual function. Because we can say that 1 pound is $2, and that 2 pounds is $4. And if we kept going, 3 pounds is $6. So can anybody tell me, what is this rule, which we're now going to call, what is the function that matches up with this input and output? What is it? Yeah. $2 for what? $2 per pound. Now, we're going to use a variable instead of saying $2 per pound. We're going to use X for pounds. So how could we write this? Yeah. Okay, so I'm going to just change it, but say $2 per pound, or 2 times X. Okay? Now, when we put in our value, and this is what they showed you yesterday in the video, if you watch Berger, he said that we keep this 2 the same, then we're going to multiply, we're going to put this 1 in for the X. And our value of Y is just 2 times 1. Then we can take it a step further and create an ordered pair. Would everybody agree that when X is 1, Y is 2, based on this graph over here? If we go to the origin, go over 1, up 2, there it is right there. Okay? So those are the things that you're going to be doing today. Now, we can do the same thing. Say 2, plug in 2 for X times 2, and we get a grand total of 4. And our next ordered pair, when X is 2, Y is 4. So now, can we figure out what happens when X, how much is it for 10 pounds? 10 pounds. Yeah. A grand total of $20. If we take $2 for each of those 10 pounds, we would have to pay a grand total of 20. And if this stretched all the way over to 10, we would go up all the way to 20. And guess what? That point would be right on that line. Does that make sense to everybody? Okay, so now let's go a step further. That's just for 4-4. Now we're going to talk a little bit about 4-6 and a little bit about 5-3. 5-3 is also included in this unit. It's the one on slope. Okay? And I want to go specifically to that unit rate was $2 for 1 pound. Do you see any relationship between your function and your unit rate? What do you see? Do you see the unit rate in your function? In fact, I said it earlier, that it's $2 per pound. $2, if X equals pounds, $2 per pound. Do you see that? Or $2 for 1 pound. If we go and look at this equation right here, y equals mx. The letter m is considered your slope. So that 2 is considered your slope. And all slope is just a ratio of rise over run. Okay? So I could say that my slope is 2. That means I can make any ratio that's equal to 2, and it's going to work for me. And I'll show you how we can use that on a graph in just a second. So we can tell the easiest one to use for a ratio of 2 is 2 divided by 1. Everybody agree with that? Okay, what's another one that will work, a ratio that's equal to 2, aside from 2 divided by 1? And let's keep it small. If we do 200 divided by 100, I can't show that on my graph. So keep the numbers as small as we can. Yeah. 10 over 5. Again, 10's a little bit, so can we go a little bit? But 10 over 5 works, right? Because 10 divided by 5 is 2. It would work in what I'm going to show you in a second. 4 over, thank you. There's a really small one, right? We could also say that 2 is equal to 4 over 2. Now I said slope is a ratio of rise over run. So watch. If I start on any one of the points, and so I'm going to start off in the origin and say I'm going to go up 2. So I'm rising 2, and then I'm going to run 1. I'm right on this point right here. Okay? Now, from right here, I'm going to say the slope is still 2, but I'm going to use 4 over 2. If I go up 4, 1, 2, 3, 4, and then slide over 2, 1, 2, I'm right on that point. So if we can figure out the slope, if we know what the slope is, all we need is 1 point. And then we can graph that line based off of the slope. Kind of a neat concept. And the reason why is because this forms a straight line. So this y equals 2x is considered a linear equation. Another one of those terms that we wrote down earlier. And it's going to be your job throughout this chapter is to write functions, to figure out slope, and then hopefully you can understand that when you find unit rate, your unit rates and your slopes are very well connected. Everybody saw that right here. Your functions and your unit rates are going to be very well connected. Now there might be additional pieces, and when we get to 4.6, there's a little bit more to it, and we'll go beyond 4.6 a little bit and talk about some things, but that's the basics of what we need to know. And hopefully if you want to go back, here's a good video, good starting point for you for some of those things. Okay?